Let me start here. You guys take out a ruler, you measure something in front of you. Let's say it's 1 foot. Okay, it's 1 foot. I know this is not in your packet and you don't need to write down anything. Let's say it's a foot. Are there other units I could have measured that object in? Yeah. Like what? Inches. Oh, well, all right, inches, right? I could have done it in inches. Anything else?
Millimeters.
All right, yeah, good. We're getting crazy. Centimeters. I could have done it in millimeters. I think we said in my first period class, go with some yards. All right, we could measure in different units, right? Angles. That's what we have done the last 2 days is graph angles. And in your entire high school degree, what type of units do you use to measure an angle?
Degrees.
Degrees, right? That's it. You don't know any different. It's always, there's no other option until today. Okay, I'm going to show you that there's another unit to measure angles in other than degrees, and that unit is called a radian. Okay, I can measure angles in what's called radians. So, for instance, we had the classic, what did we use yesterday a lot? 120 degrees. I'm going to show you today how to convert that into how many radians it is. Okay. So just want to introduce, you can measure an angle in degrees, and now I'm going to introduce, you can measure it in radians. Why am I showing you this? Because this is the type of unit we're going to be in probably the remainder of the unit. Because we're going to do things in radians instead of degrees. So let's actually, I'm going to skip number 1 here and come back to it. Let me go to that 120 degree example. So go to number 2 real quick. How do I convert 120 degrees into radians? So I'm asking, hey, 122 degrees is how many radians? It's a conversion. It's something you got to multiply by, and it's on your formula sheet, which is great. I don't have to memorize this. It's on the formula sheet. So everyone, and it's on your packet too, but more importantly, your formula sheet. So everyone look on your formula sheet to where it says degrees equals radians. Everyone see where it starts with degrees equals radians. And then you have this fraction here, which is pi over 180. That is what you multiply any degree measure by to turn it into radians. So I'm going to take 120 degrees times on my formula sheet pi over 180 to convert it into degrees. Time out. Don't do it, though. Don't do it. Don't do it. I'm going to do it. And you're going to tell me, you've known me for about, what, 6-7 weeks now, the problem I'm going to have when I do this. So get rid of that. I'm going to do 120 times, here you go, get my fraction out, pi over 180. So that's how many radians, 2.09 are in 120 degrees. Anybody know what problem I'm going to have with that? That's kind of gross. It doesn't end, keeps going on. Let me just quick check math fraction. Can I turn it into a nice, nope. I don't want that. I don't want that written out, 2 point whatever radians. All right, I don't want, it's too long and it's too disgusting to write out. All right, it doesn't mean too much. So instead, to clean this up a little bit, when you write your answer in radians for me, I would like you to keep the pi in your answer. All right, to clean this up a little bit so I don't have to write 2.09 all the way on. Keep the pi in your answer, and now for me, reduce 120 over 180. Clean that up a little bit, 120 over 180. Go to your calculators. I've shown you this before. Your calculator reduces for you. You just got to put it into fraction form, 120 over 180. And it'll reduce. So instead of writing 2.094 so on, we're instead going to say in 120 degrees, there are 2 pi over 3 radians. Okay? 2 pi over 3 radians. That is how I'm going to turn degrees into radians. I'm going to multiply everything by pi over 180, and to keep it clean, keep the pi in the answer. Yes, Alexa.
Are you ever just gonna get a clean number and you're gonna not have to leave pi?
You're always gonna have pi in your answer. Yeah. You're never gonna get a clean number. Good question. Unfortunately not. All right, so that's how I go from degrees to radians, and we're gonna have to go backwards now. So now go back to number 1, and that is how do I turn a radian back into degrees? Because I want to go make sure we can go back and forth. Before we do that, Usually, I'll say about 99% of the time, how am I going to know an angle's in radians? You're going to see that pi there. Oh, that's in radians. 99% of the time. I'll show you that other 1% after we do this problem. So I'm going to take 7 pi over 6 radians and convert it to, I don't know, we'll figure out in a second how many degrees. It's on the formula sheet. Ready? But here's the thing. You got to find radians to degrees. Radians on the left, degrees on the right. Find it on your formula sheet. Everyone see it? What am I multiplying by now? Not pi over 180. That was earlier. Now it's 180 over pi. Everyone see that on the formula sheet? It's telling me to multiply by 180 over pi. And you know what? That kind of makes sense. What's on top and what's on the bottom that's going to cancel out? Yeah, that makes sense. They're gone. See ya. See ya. So now I'm just doing 7/6 times 180 to get that angle in degrees. $210? Okay, so 7 pi over 6 radians is the same as 210 degrees. All right. Questions? So usually when I see an angle measure that's got a pi in it, it's in radians. The other 1% of the time, it may not have a pi with it, but I'll still tell you it's in radians. So here you go, 5.8 radians. 5.8 radians. What's the angle measure? In degrees. All right, one slight change will happen here. So I take my radians. Look on your formula sheet if you ever forget. I have radians. I'm going to degrees. What do I multiply by? 180 over pi. Here's the slight change. Are the pi's going to cancel? No, they're not. That's it. There's the slight change. I'm still multiplying by 180 over pi to convert it, but the pi's won't cancel. All right, no problem. So here you go. 5.8 times 180 over pi. And yeah, I get a long decimal there, but I do have rounding directions, which I'll always give you. Round to the nearest degree. So 5.8 radians is the same as 332 degrees. So that's the only change. Yes, Libby?
So like you only want us to do the like where we leave the radian or the pi in when we're turning it.
So when you turn an angle in degrees into radians, I want the pi there, yes. Okay? I want the pi there. I don't want it rounded by yourself. Leave the pi in your answer. All right, what about negative 2.5 radians? Hey, did we deal with negative angles yesterday? All right, negative degrees, I should say. Did we? Okay, so you can have negative radians. All right, so your answer should be a negative degree here at the end. Let's see. Negative 2.5, still multiplying it by 180 over pi. Okay, pi's don't cancel out. Oh well, I guess I'll just have to plug it in my calculator. Luckily, I have rounding directions for you. Negative 143. Questions from you guys? So that's a quick little lesson on how to convert from radians to degrees, degrees to radians. Anything you want to ask? Here's what I want to do for the rest of class. Everything we did the last 2 days, graph an angle, find the reference angle, find a coterminal angle. I want to do it all again, but now in radians. Okay, so don't forget what you did in degrees. Don't forget what you did in degrees the last 2 days. Now I just want to do it all in radians. Here's my angle. It's in radians. I see the pi. It's in radians. Give me a positive and a negative coterminal angle with it. Review. Review. Last 2 days, if I gave you 130 degrees and asked for a positive coterminal angle, what would you do with 130? Add what? Okay. And if I asked for a negative, what would you do with the 130? All right, well, guess what? I can't add and subtract 360, right? Because I'm in radians. Wouldn't it be nice to know what the equivalent is in radians, wouldn't it be, of 360? Because that's what I would add and subtract. Everyone see where we're going here? Yes, you would add and subtract 360 a couple days ago, but now I'm in radians. So what is 360 in radians? Can you help me find it? You guys know how to convert? All right, help me find that. Ready? I got 360, 360 degrees. I want to know what it is in radians. Degrees, radians. Degrees, radians on your formula sheet. What are we multiplying this bad boy by? Good, good. Pi over 180. I don't want that decimal. Get it out of there, but keep the pi there. 360 over 180. Let's reduce it for me. 360 over 180. You're just finding it's 2? So 360 is the same as how many radians? 2 pi. There it is. There is the conversion right there. Anytime I need 360 in radians, I use 2 pi instead. Are you ready? There's only one response, so. 5 pi over 2. Let's find another positive coterminal angle. What do I need to add to it? Not 360, but 2 pi. And don't start giving me crap here. You can do this. All right, you can do this. I wouldn't have shown it to you this way if I didn't believe in you. You got 2 fractions with different denominators, don't you? All right, so let's combine them into 1. You're fine. 2 and 1. Give me a break. What's the common denominator?
2.
Okay. Do I need to multiply anything over here with the 5 pi? No, right? Because it's the same common denominator. So 5 pi, 5 pi. What do you got to multiply the next fraction by?
2.
Oh, is everyone all right? Multiply it by 2. 2 pi times 2. 4 pi. Yeah? So what's another positive coterminal angle, but now in radians? 9 pi over 2. Good job, guys. You can do this. You can do this. No problem. Now ready to find the negative angle, coterminal. Now what do you want me to do to these two? 5 pi over 2 minus 2 pi. Haven't you guys have already done the work here? Right? What's your common denominator still? 2. It's still going to be 5 pi. Now it's minus. What do you still have to multiply 2 pi by? 2, right? So it's still minus 4 pi. Ooh, what are you going to get there? What am I going to get? 5 pi minus 4 pi. 1 pi over 2. Guys, what's the problem? Cripe. I didn't answer the question yet. Why not? Not negative. So what would you have done a couple days ago then if it wasn't negative yet? Keep subtracting 360. Now subtract 2 pi again. Common denominator still. 2. Do I need to change the pi over 2? Nope. So pi minus, what's this still going to be? Do I keep it 2 pi though? I still got to multiply it by what? 2, right? So it's going to be minus 4 pi. Oh, do I end up with a negative here? Finally. So what's a negative coterminal angle? There you go. Negative angle, positive angle. I'm doing the same exact thing, except not adding and subtracting 360. And you got a little more math involved because you can't just hit your calculator and go. Questions on getting that? 2 pi equals 360. That's the big conversion there. 2 pi equals 360. Questions? All right, so we know coterminal now. Let's graph an angle in radians. Negative 5 pi over 6. Graph it. Oh boy. Sorry, I'm not a big fan of this one. I don't know how to graph in radians. But you do know how to graph in what?
Degrees.
Do you know how to convert now? I think we got a solution. Okay, I think we got a solution. I don't know how to graph in radians, and you know what? I'm not going to teach you because that's too much extra for everybody. So, but we do know how to graph in degrees, and we know how to convert this to degrees now. Look on your formula sheet. 180 over pi times 180 over pi. Cancel out the pi's. What are you guys going to graph? Negative what? 150. All right. We can do that, I hope. Just took that quiz, I hope. Initial side on the x-axis, positive side. I should be calling out people, but we're just rolling it wrong, so I'm not going to stop it. Where's negative 150? If it was positive, it would be. We're negative. Come on, got to go clockwise. Third quadrant. Yep. Closer to negative 90 or negative 180? Yep. So let's make it look like it. Negative 180. Where's that arrow going?
Clockwise.
And I don't know, I haven't even sniffed your quizzes you just handed in, but I graded first periods already. And there's some people still having issues with the rotation arrow. When you start the rotation arrow, you start it right there on the initial side and go from there. All right, so now it's right there. Okay, some people started it on the y-axis up here. I was like, what's going on? Start it on the initial side, please. All right, so good job graphing. And then there is a second question, which is, what's the reference angle? But it's got to be in radians. Everyone see it? Where is the reference angle up here? Do you see it?
Yeah.
Our work from yesterday right here. Finding that reference angle. Just do it how you've been doing it. Just do it how you've been doing it. We got negative 150. I believe nobody likes negative angles in here. They like to find a reference angle using a positive angle. Okay, so how do you make negative 150 positive? Okay, guys, we're doing the same exact stuff we did yesterday, except I got one extra step at the end. So that's the same as 210 degrees. All right. What do you do with 210 to find the reference angle in the third quadrant?
Subtract it from 270.
Oh, don't you ever say that number.
Sorry.
Or 90.
360. Maybe.
I'm in the third quadrant. You're all rattled.
Subtract 180.
210. The reference angle is going to be?
Oh!
Reference angle will be 210 minus 180
Sorry.
for a reference angle of 30 degrees. Everyone please read the directions though. Yeah. Reference angle has to be in radians. So suggestion?
Convert it.
Convert it. Convert it. You guys know how to do all this stuff. It's just at the end, everything's got to be in radians now. So 30 times, look on your sheet, degree radian. What am I multiplying this bad boy by? Oh, pi over 180. Leave it clean, leave it clean. Leave the pi in your answer and just reduce 30 over 180. One pi over 6, yep. So what I'm trying to tell you here, guys, work in degrees, that's fine. You just got to make sure at the end we convert everything back over to radians. Okay? What's up, Sarah?
So, can you write 1 pi or can you just write? Okay.
Sure. If that makes you warm inside, go right ahead. Questions? So work in degrees, I don't care. Just make sure at the end it's in the right units, radians.
For that, so you just find the highest. Great. Because when I put it, you don't put it in your calculator, right?
What do you mean, 30 over 180?
Yeah. No.
Yeah.
Oh. Yeah, no, never mind. I got it.
You good now?
Yeah.
Okay. The less thinking, the better for you, right?
Mm-hmm.
13 pi over 8. Some of you guys are already clicking away there. Good. All on the formula sheet. 180 over pi. Pi's cancel. We got a little decimal action here, huh? What's 13 pi over 8 in degrees? 292.5. Is that what it was?
Yeah.
So you got your initial side. What quad am I in? 4, closer to 270 or 360.
270.
All right, good. Where's my arrow going? Counterclockwise, start on the initial side, and boom, go with it. Ready for the reference angle? How would you find the reference angle in degrees?
360.
Yep, it's in the fourth quadrant, so 360 minus the angle. Hmm. 67.5.
Yeah.
Just good memory from first period. That's all that is. No mathematics. Degrees. Final answer in radians. So multiply it by. Yep. Keep the pi in the answer. And some of you guys might get a decimal out of this. Convert it back into a fraction. Math fraction at the end. It will convert back to a fraction. So if you guys got 3.375, hit your math button, change it back to a fraction. And the fraction we should have is 3 pi over 8. Welcome to Radians. Start your delta math. So this is exactly what we just did right here. 2 questions tomorrow on the pop quiz involving radians. Notebook paper on page 11 for you if you need to jot down anything for the delta math.